Here we have another important theorem, and it says that the angle subtended at the circumference of a circle by a diameter is a right angle. So a diameter is essentially a chord that passes through the center of a circle. So this is the diameter of the circle. This diameter subtends at an angle can subtend an angle at any point on the circumference of the circle. So it can subtend an angle at this point P1. This is an angle. It can also subtend an angle at this point P2. So let me just mark out the center. It can also subtend an angle at this point P3. But what this theorem tells us is that, that's this angle here, is that the angle subtended by a diameter, as you can see this line AB passes through the center, is the diameter, at any point on the circumference is a right angle. So all the angles here are right angles. So it's easier to demarcate them as right angles using this symbol. So this angle here is a right angle. It's the angle subtended by the diameter at point P2. This angle here is the angle subtended by the diameter at point P3, where P3, P2, and P1 all lie in the circumference. So those are right angles. So imagine a situation where you just have this diagram, a straight line, and you're told that point O is the center of a circle, and then essentially what you have is a triangle, and you have this angle. You're told this angle is 30 degrees. You're asked to work out this angle X. Well, by applying this rule, you simply know that the diameter subtends an angle at this point. An angle is a right angle. So this angle is 90 degrees, this is 30 degrees. So we have 90 plus 30. What do you know about the sum of angles in a triangle? They all add up to 180 degrees. So you know that 90 plus 30 plus x must be equal to 180 degrees. So you know that 120 degrees plus x is 180 degrees. So you know that x is 60 degrees. It's as simple as that. The second form of this theorem is saying pretty much the same thing. It's saying pretty much the same thing because it's saying the angle subtended at the circumference of a circle by a semicircle as opposed to diameter is also a right angle. Again, we have a diameter here. You know, a diameter, we'll split a circle into two semicircles. This arc here of one of the semicircles, so this arc that is the boundary of one of the semicircles, well, the curved boundary of one of the semicircles, can subtend angles. It can subtend an angle at that point, so this point here. The same rule is that this angle is a right angle. It can also subtend an angle here at this point in the circumference. The rule is that this angle is also a right angle. Why is it the same as the first one? Well, if you think about it, you focus on the diameter AB for a bit. You call this point P1 and P2. The angle subtended by diameter AB at P1 is this angle here, this 90-degree angle here. And to get that, you join A to P1 and B to P1. What about the angle subtended by this arc AB at P1? Well, you join A to P1 and B to P1. So you can see that you get the same angle, hence why they're both right angles. Similarly, AB diameter subtends an angle here at P2. According to the first sentence, you know it's a 90-degree angle, and the way you work it out is the way you form the angles, you join A to P2 and B to P2, and you have this angle here. Well, similarly, to find the angle subtended by arc AB at P2, you join A to P2 and B to P2. So you're drawing the same lines. So of course they're going to intersect and form the same 90-degree angle. So there you go.